Hello, my name's Andy Glover. I run delivery engineering for Netflix. I'm really happy to be here in Vegas. Looking around, I still see that most of you have not lost your shirts. I basically lost my shirt Monday night, and like every good person with a gambling problem, I gambled on Tuesday night and almost lost my shirt again. In fact, got down to my last couple dollars, and a good friend actually lent me some money to keep playing because I don't have a gambling problem. And amazingly enough, through his good advice, I won all my money back plus his. So I'm back to even, and I'll probably gamble tonight. So I love Vegas. Hopefully you're having a good time as well. So again, I run delivery engineering for Netflix, and in this talk, I'd like to share with you three things: how we facilitate global continuous delivery, the many lessons we've learned along the way, and then consequently the best practices we now advocate. So are there any Netflix members in the room? Thank you. We love you very much. Thank you for your continued binging. You can now download videos to your favorite device. Hopefully some of you saw that. It's good stuff. So now you can watch all your favorite content on the flight home. So thank you very much for your continued support. As you've probably figured out, I work at Netflix. I love working at Netflix. It's the best job I've ever had. And one of the best things about working at Netflix, and what I really appreciate about the culture and the people at Netflix, is that we are laser focused on winning moments of truth. Everything we do is focused. All right, first error of the, there we go, over-clicking. Everything we do is focused on making your experience the best it can be. Whether it's to offer more content choices, more supported devices, or even better recommendations. We focus so much on the experience because we want you to choose to watch Netflix, whether it be on the plane or when you're working out or at your home. We want you to watch it again and again and again. Consequently, we strongly believe that speed is a competitive advantage. We know that if we're not fast, our competitors will be. We also know that our customers, you all, demand that we're fast. And finally, the faster we learn, the faster we can evolve to keep you happy. All right, it's pretty dry in here. So earlier this year, we launched in 130 countries. And to facilitate a global audience, we obviously rely heavily on AWS. And accordingly, we operate out of multiple AWS regions around the globe. Operating at this level of scale requires sophisticated tooling that ultimately makes it easy for development teams to move fast with a high degree of confidence. And ladies and gentlemen, that's why we built Spinnaker. Spinnaker is evolutionary. It's built on the shoulders of giants. It's built on top, or it takes the many lessons learned from multiple systems that have been built throughout the years at Netflix that have facilitated continuous delivery since we went to the cloud over 6 years ago. And Spinnaker is a continuous delivery platform that orchestrates the delivery of software assets, whether those assets be an AMI or AMI, a Docker image, a jar file, a JavaScript application. It doesn't matter. It's flexible to handle what you define to be a software asset. And ultimately, Spinnaker facilitates moving fast at a global scale. It accelerates our time to market. Spinnaker empowers teams to make rapid changes with confidence and thus enables a focus on building the right product for you all. As a platform, Spinnaker has improved developer productivity and efficiency. And the good news is that Spinnaker builds on the concepts spearheaded by a previous cloud management platform called Asgard. Asgard was open source many years ago. Maybe some of you in this room are familiar with it. And Asgard did something really spectacular for Netflix and hopefully for the industry. And that is it created a model. And in fact, it created this concept of an application. And an application is comprised of clusters. And clusters are comprised of auto-scaling groups, or ASGs. Everyone in this room is an AWS fan, so hopefully you all recognize an ASG is the top-level compute element in AWS. And it's also tied to a region. So this application-centric modeling is key to maintaining a global infrastructure, because you can have an app that's a global app and then has, obviously, ASGs distributed around the globe. A key point I want to make about Netflix is that there aren't any centralized DevOps teams at Netflix. For instance, the Spinnaker team, we're focused on building and operating Spinnaker, not on building specific pipelines for teams. As such, teams at Netflix, they own their own destiny, and they make their own pipelines in Spinnaker. And so this is a key point. There's no release team at Netflix. There's no centralized ops team that manages production. If you're an app owner, it's up to you to put that app in production. You have total ownership over it, so consequently, if that app goes sideways at 4 a.m. on a Saturday night, you're the one who gets the page, and you're the one who's expected to solve that issue in a timely manner. So Spinnaker acts as a standard platform that enables all the benefits of continuous delivery at Netflix, so it's really a paved road. Teams are not required to use Spinnaker. They can go off the paved road, but as the analogy serves, it's kind of bumpy and you're kind of charting your own course. If you're on the paved road, you're able to move as fast as possible. It's paved, and it's a straight line between point A and B, point A maybe being some test environment and B being production. And the good news is because it's a paved road, it codifies all the best practices that we as a company have learned, and we can put them into Spinnaker so that each team can take advantage of it. And the beauty is if one particular team discovers something new or innovates something interesting, they can then add that lesson learned or that component or that feature or that platform into Spinnaker, and then everyone gets to take advantage of it. And so as a paved path, it provides that standard means to plug into a greater infrastructure of integrated tools and platforms. Tools like Chaos Monkey, which I suspect many of you have heard of. It's incredible. It's awesome, and I'll get to it in more detail in a little while. Other platforms like our automated CANARY analysis platform, which is spectacularly sophisticated, awesome. It's plugged into Spinnaker so that everyone can take advantage of it, and I'll talk about this more in a little while. And there are other tools like this that are plugged into that paved road and that everyone gets to take advantage of it. So Jez Humble, he wrote a book on continuous delivery. In fact, he wrote the book on continuous delivery. He put it best when he said, quote, "Continuous delivery is ultimately about making deployments boring," end quote. So what that means is deployments are no longer this event. They're not this thing that, back in the day, it was a scheduled event on Friday, all hands on deck, we're deploying. Deployments just happen. They happen all the time. And in fact, at Netflix, we've been running Spinnaker now for over 2 years. And in that time, we've seen deployments double from around 2,000 a day to 4,000 today. But I got to tell you, in that time, we have certainly seen our fair share of disasters. And hopefully you haven't, though. Due to the amazing kind of resilient architecture with fallbacks that we have in Netflix, a lot of the disasters that occur you're not aware of. Sometimes you might be aware of some of them. But suffice to say, disasters happen at Netflix, and we've learned a ton of lessons, and I'm here to share a lot of those lessons with you. But something key that I want to stress, and I'll stress it throughout this presentation, is that we have a blameless post-mortem culture. And what's more is we feel very strongly that guardrails are far more effective than gates because we trust our employees to make good decisions. We accept that occasionally failures will happen, but putting draconian measures in place to prohibit the possibility of mistakes only serves to slow people down and probably diminishes opportunities for innovation. So if you've ever gone to another presentation by a Netflix employee or looked at any of the software that we've open sourced, especially if you look at Spinnaker, you've probably ascertained that we have some very strong opinions about how to do, in this case, multi-region software deployments that are both rapid and reliable. And so I'm going to share with you some of these opinions. I talked about Spinnaker, and I'll show you examples of how we codify these best practices within Spinnaker. But I want to stress these best practices aren't unique to Spinnaker. They're delivery best practices regardless of your platform of choice. So, first and foremost, even though our particular tooling facilitates simultaneous regional deployments, we don't recommend doing them. In the event of a bad deployment, for whatever reason, that will eventually pop up, be it a software bug, infrastructure outage, AWS hiccup, which never happens. Keeping deployments focused to a region means your blast radius is limited, as opposed to if you deploy to the entire globe, then if there is a hiccup, then your entire global audience is affected. So what I want to do throughout this is show you examples of how we facilitate this within Spinnaker. So for instance, in this case, this is obviously a screenshot of Spinnaker if you haven't figured that out. But this is a screenshot of Spinnaker for those of you that didn't figure that out. And this is a particular pipeline that is dedicated to a deployment in US East. We're in multiple regions, as I already said. And what's more, this particular pipeline also does something interesting that I'll talk about also shortly, is that it leverages something what we call is a deployment window. But the key point is, and then if you look below it, there's another pipeline that's deploying to another region. Now again, Spinnaker does not prohibit you from creating a pipeline that can deploy to multiple regions. So for example, if you deploy to 2 regions, in Spinnaker, you can certainly have a single pipeline that either has 2 deployment stages or 1 deployment stage that simultaneously deploys to 2 regions. We feel very strongly that that's a terrible idea to create 1 deployment stage that deploys simultaneously, but you could certainly have a single pipeline that has 2 stages. So a pipeline is made up of stages. And you could insert some sort of logic between those stages to perhaps wait, verify that the previous deployment went well, and then the next deployment's OK. It'll become apparent as I go through some of these more additional best practices why multiple pipelines are probably a superior idea. But again, our tooling does not prohibit you from doing what you deem necessary if you want to make 1 pipeline. So remember, in a fast-moving environment, it's really tempting to push software globally all at once. Please take it from us, don't do it. Take advantage of AWS regionality and limit your blast radius. Deploy to one region at a time, and ensure that that region is properly functioning before you go on to the next. And if you want to think about it from Spinnaker is a sailing term, so think in terms of ships. Big ships, like the Titanic, they're made up of compartments. Let's not think about the Titanic. Let's think about a ship that actually didn't sink. But ships have compartments, right? And so if the hull is breached, you can seal up that compartment, and ideally the ship doesn't sink. Same way to think about the globe and regions. Those regions are your compartment and your bulkhead. You can seal it up. It only affects that particular region, and the rest of the world isn't affected. So limit your blast radius. Please don't do simultaneous regional deployments. So red-black deployments, or as the rest of the world calls them, blue-green. This style of deployment is your friend. So a red-black deployment, it takes advantage of AWS elasticity, where the next version of a particular software package is stood up in a completely new, separate ASG. And once health checks pass in that ASG, the previous ASG is then disabled and traffic is routed to this new one. And so you have essentially twice as much capacity being used. But the benefit here, right, is that in this new ASG, if something goes wrong with it, you can quickly enable this one and then route traffic to it, disabling this one, and you've hopefully limited the amount of time that people are affected. This is key. This is a deployment strategy that's much different than, let's say, rolling deployments or in-place deployments. So in this case, the arrow is pointing to an ASG that was deployed to EU West 1. And it's enabled. And you can see that it was red-blacked into this environment because the previous ASG is in a disabled state. And so you can see in this particular stance, if that ASG, for whatever reason, goes sideways, maybe a bug surfaces later, or you name it, something happens, that team, through either automation or manual steps, which I'll show you next, can disable that ASG, enable the previous one, disable that one, and then route traffic to that, thereby limiting how long people are affected. And so in this case, in EUS1, that particular ASG is enabled. There's a previous ASG that has 0 instances, but nevertheless, it's still around. It's hanging around and the launch config is still valid. So in this case, there's a button you can press, enable rollback, right? And that'll roll back ostensibly to whatever ASG you think is important, or you would like to go to. So red-black deployment as a style of deployment, as opposed to rolling deployments, offer the most rapid and reliable means to back out of a bad deployment. You will have bad deployments eventually. This is a superior means to get out of it. So I kind of hinted at this at an earlier slide. So Netflix is fairly, our traffic is fairly cyclic. Our regional traffic is cyclic. And for the most part, people in any particular region watch more Netflix during the evening hours. So for instance, right now it's, what is it, like 1:20? The East Coast is beginning to ramp up. People are getting home from work, and naturally they're watching Netflix. People on the West Coast are at work, so they're not watching Netflix, hopefully. Actually, I went to a company once and tried to check my Netflix email, and it was blocked. Any Netflix.com address was blocked in my browser. It was kind of funny. I guess they had a problem. So so our traffic is cyclic. And so accordingly, teams at Netflix can take advantage of the peak and the trough, so to speak, and ostensibly they would want to deploy during a trough. And that's what deployment windows allow you to do. So they allow you to deploy during off hours so that if there is an issue, it affects a smaller amount of people. There's a side benefit to deployment windows, which I'll get to in a second as well. So in this case, you can see that this is a configuration for a deployment, and this particular team has decided that they will deploy to US East only from 10 a.m. to 2 p.m. Pacific time. And so back to the point about peak hours on the East Coast, they're trying to hit a deployment before its peak. And in fact, we provide some more context in the form of a graph that shows a particular metric that we watch very closely, which we call SPS, which is streaming starts per second. And that's, again, a very predictable number. We know, again, during the evening hours, SPS is going to spike, and during working hours, it kind of goes into a trough. So we provide this graph so we can provide that context to teams to say, hey, look, peak in the US East is at the top. And so this team's saying, hey, look, we're going to do a deployment before that. But here's the other key benefit. Note the time is between 10 a.m. and 2 p.m. That's working hours. So this team not only wants to hit this deployment before peak in US East, but they get the side benefit in that they have the most people on the ground that can potentially fix any issues should they occur. So deployment windows can limit the number of affected customers in the event of an issue. But what's more, deployment windows can ensure automation occurs during working hours when maximum coverage is available in the event of an issue. So again, I can't stress issues, bugs, bad deployments, bad things will happen. You can't stop them. And so in this case, what we're trying to do is limit how long it takes to fix it. So at Netflix, as I also mentioned earlier, we have a sophisticated telemetry platform that allows us to compare 2 different versions of running software. We call this automated canary analysis, or ACA. And with our ACA platform, we can compare 2 different versions of software taking production traffic. And it's a great last line of defense to ensure things are working well before you open the floodgates. And what I mean by comparing 2 different versions of software is the metrics associated, whether they be system metrics like memory, CPU load, disk I/O, but even application metrics. So imagine you have version 10 of your service, and obviously version 9 maybe is running out in production. So what you can do is stand up two ASGs, version 9, version 10, allow a small amount of production traffic to go to them, and then it's an apples to apples comparison. And you can set how long you want ACA to watch it. And for example, ACA may notice the newer version of your particular service has elevated error rates or a lower RPS or whatever it is. It's up to you to decide what's important for your app. And that platform will then tell you, hey, something's wrong, something's gone sideways with your new deployment. And this tool, this platform, is highly integrated into Spinnaker. So in this case, you can see here's a pipeline that's doing a production push, and it includes an ACA step. And in this case, the ACA, it was scored at 93. ACA scores are out of 100, and Spinnaker allows you to define a go, no-go threshold. So you can imagine maybe this team set a threshold as 90. And anything above 90 is good to go. Anything below 90 is thumbs down. And in the case of thumbs down, then that particular stage would be marked as a failure, and the overall pipeline would be in a failure state. And the cool thing is that with Spinnaker, then you can take some branching logic, so to speak, conditional logic based on that failure. So you could say, hey, if this pipeline fails, then run this other pipeline, which would maybe roll back, notify someone, do something important. It's really up to you to decide what that is. But the key thing is, even though this stage fails, we don't necessarily leave it in a crazy state. You can take cleanup, corrective actions. And part of the value of having this paved path is deep integration with other platforms. So in this case, you can get to a detailed report. So you can click on the link and you'll be taken to the ACA platform, and it'll tell you why it scored this at a 95. You can look at all the details and you can see, well, why did I lose 5 points for whatever reason? And this is important, and I'll get to this. A lot of these best practices are additive. But note, again, this deep integration, and you can go to these other platforms from within Spinnaker. So the data combinatorics in a complex microservice architecture like what we have in Netflix, it makes it cost prohibitive to test every possible path before releasing something into production. Consequently, ACA allows us to verify things are working well in production with live traffic, and Spinnaker makes it easy for us to back things out should this last particular stage or gate uncover some issues. So invariably, there are one-off infrastructure management tasks that people execute from time to time. These could be emergency fixes or even occasional updates to infrastructure. And it's easy to overlook automating these things, but that's bad because manual tasks tend to create towers of knowledge. By codifying this automation into pipelines, anyone can run them with the benefit of consistency. So here's an example of kind of one of these once in a million events that thankfully this team automated. Here's a pipeline that can be used in an emergency situation to deploy to any region via parameter. So you can imagine this probably happened once. They were running version foo, and it was going fine, and all of a sudden something went haywire. And they probably manually figured out, okay, we'll roll forward, we'll do X, Y, and Z. And thankfully, this team then decided, well, we never want to do that again because that particular individual, Cindy, she likes to leave at 5:30 to go home, and this happened particularly, it happened to happen right around 5:30. So let's make a pipeline, codify it, and that way, if it happens again at 7 p.m. or whatever, anyone can run this. It doesn't rely on Cindy's knowledge. Here's another example of a pipeline that sets a runtime parameter or a runtime, environmental property based on a parameter. So we have an extensive dynamic configuration system at Netflix. We call it persisted properties, but think of it as you can have a running app, and you can change properties of that app, and that app can look for those properties. So imagine a property like send or make House of Cards live. And rather than deploying a new app or restarting it for it to pick up that property, you can go to a different console, a different system, and say House of Cards live equals true. And then any app that has that House of Cards live parameter, once it changes from false to true, then can do whatever it needs to do based on that parameter. And that's done via this persistent properties infrastructure. But note, that's kind of manual, right? You go to this other system and you find that parameter and you say true, and all of a sudden, boom, the entire globe now has this value as true. And so with Spinnaker, what we're advocating is making that, it's a deployment, right? And you can codify that in a pipeline. And so rather than going into this console and manually saying, this is now true, you can go into Spinnaker and create a pipeline and say, I want to set it to true and I want to limit the scope. Maybe I want to set it to true, but only for a couple instances over here. Once that's good to go, then I'll set it to a larger scope and a larger scope. So again, that bulkheading strategy, facilitated through pipelines within Spinnaker, avoids global disasters. So automation is a no-brainer. Anytime a task is manually executed more than once, consider it an opportunity to create a pipeline. Otherwise, you risk creating towers of knowledge that become problems when those individuals aren't around to execute those tasks. We have seen this at Netflix. I'm sure every one of you has a story throughout your career where this happened. And that's why it's a no-brainer to automate this. But you'd be surprised how many manual things every one of us do from day to day. So, email. Email is a terrible way to get someone's attention. In fact, I'm sure in this talk alone, the total emails sent to all of us is well over 100,000, and 20% of those are from Nigeria. And there's some other ones in there that I won't say. So at Netflix, we've seen on more than one occasion that emails requiring action have inadvertently been missed. So therefore, when it comes to notifying people of important events or actions that need to be taken, such as deployments or manual stages, we recommend using alternate channels like Slack, HipChat, SMS, anything but email. So here's an example. In this case, here's a pipeline that uses email and Slack to notify relevant people when this pipeline starts, when it completes, and most importantly, if this particular pipeline fails, the pipeline is specifically configured to notify a support channel in Slack. So this team really wants to be notified ASAP if something happens, if something goes sideways. And here is an example of a Slack notification that a deployment into production completed successfully. Again, this is important information that people need real-time, or potentially want real-time status of. That we are now aware that something went into production is helpful context should an alert get fired or something happens and we want to understand, well, was it related to, what changed? Oh, look, this thing went into production, it's probably related to that. And here's a notification that requires a human to take action. So in this case, this particular notification is asking a human to approve a deployment into a particular environment. So email was never intended to be a real-time communication mechanism. Consequently, if particular events require immediate action to be taken, use alternative channels like Slack, SMS, HipChat, you name it, whatever floats your boat. But I would highly recommend you don't use email. So, the machines thankfully haven't completely replaced all of us. Sometimes we're actually needed. Consequently, Spinnaker has a specific stage that we call manual judgment, where someone, i.e. a human, must manually initiate a positive or negative acknowledgement. So here's a manual judgment stage following an automated CANARY analysis. And in this manual judgment stage, there's an actual button for a human to press that either stops the pipeline or allows it to continue. And as you can see, following that manual judgment is a deployment into production. So again, here's this orchestrated workflow that facilitates a deployment into production with a kind of a safety valve right in the middle. The CANARY report could come out with something on a borderline, and a human can look at it and say, you know what? We've seen this before. Elevated, elevated exceptions, they're transient. It's not going to affect anything. So we're going to go ahead with this deployment, or vice versa. We've seen this thing before. Even though ACA say it's all right, I don't feel good about this. We're going to stop this deployment right here and there. So what differentiates humans from machines is that we understand nuance, and frankly, we have a gut. And at Netflix, we trust our engineers to use that gut. Manual judgment can be a powerful stage that makes sense in certain situations. You all know what happens when you assume, right? Like one person nod their head. No one, your teachers never said this? So, don't assume it makes something out of you and me. Things change. Entropy is really a thing. Therefore, guard against it. We have seen this time and time again. But here's the epitome of recognizing that entropy is something. And this is the epitome of not assuming reliability. And it's Chaos Monkey. If you don't know, Chaos Monkey is a system that we run at Netflix that randomly kills running instances. It's tightly integrated into Spinnaker. In fact, you get it on by default when you create an app. You have to turn it off. And so in this case, it's part of the ethos of our culture at Netflix that demands service reliability. We make no assumptions that if your service gets shot in the head, that it actually is going to work. So we test it all the time in production. And in Spinnaker, you can configure kind of how you want Chaos Monkey to actually introduce chaos. Here's another great example of a pipeline that's triggered by a cron expression. But note in this case, this cron expression excludes the weekend. This particular pipeline is deploying into production. So you can tell that this team really wants to be sure someone is around in case, again, something goes wrong with this deployment. And I suspect this particular team also enjoys their weekends. And we have seen this, again, as a lesson learned, that automation that runs over the weekends, it works 1,000 times. And then there's that one weird scenario where it doesn't work, and it just happens to happen at like Saturday morning at 3 a.m. And getting a hold of someone at 3 a.m. is possible. It just takes a little longer than looking over at the person next to you and saying, something went wrong, please fix this. Here's an example of a pipeline taking advantage of a stage we call a precondition stage within Spinnaker. So pipelines can take a long time to execute, especially if you use a deployment window. So imagine there's a pipeline that only deploys between 10 a.m. and 2 p.m. And you make a change to the code, the pipeline's kicked off at 8 a.m. So that pipeline's going to wait 2 hours before it throws that thing into production. And the challenge you have there is that the underlying cloud, the infrastructure of AWS may have changed underneath you in that 2-hour span. And so we've seen this as well, in that a pipeline is kicked off, and it waits for a little while. And then someone else on your team manually goes in and changes something. Maybe they stand up a new ASG, or they delete an ASG, or they resize it. It doesn't matter. And so the idea here is that, again, by not making assumptions, by adding preconditions into your pipelines, you can ensure things are as they should be before a particular stage executes. Netflix believes strongly in the value of immutable infrastructure. There are a number of benefits that one derives from immutable infrastructures. First and foremost is consistency. So what we do at Netflix is we bake everything up front. It takes a little longer to create an AMI, but then we use that same AMI through environments. And that AMI has all its dependencies baked into it, i.e., when we stand something up in production, we don't make calls to Artifactory to download any dependencies. or any third-party systems. Everything that app needs to run is already baked into that AMI. And so we have this notion of a find AMI stage that you can pull an AMI from any environment and pull it forward into a forward environment. So instead of creating an AMI for every environment, because there's a promotional stage here where you could go from test to pre-staging to staging to production. What we do is bake once and use that same AMI through all those different environments, rather than baking each time. And so here's another example of a find AMI that's going to run before a CANARY, and then that is going to go into production. So the only change, or the only constant, is change. And embrace it, and construct pipelines accordingly. Otherwise, you run the risk that things will break because you base it on assumptions. And I guarantee you, when it breaks is the most inconvenient time, the worst possible situation in production on a Saturday morning or Saturday evening when you can't get a hold of anyone in a timely manner. So, again, these things are very much additive. Even if you follow every best practice that I've outlined here, failure will eventually happen. So you might as well make it as easy as possible to reduce the time to fix that failure or that issue. So in Spinnaker, we tightly integrate with PagerDuty. So you can see here there's a button that if you know that there's a problem with this particular app, you can go find the little red Batman phone, click it, and it pages that team or the on-call person for that team immediately. So yeah, we've made it super easy. And in fact, PagerDuty keys are required when you define an application. We have learned some lessons from this. Our tight integration with PagerDuty makes it super easy to link an application with a PagerDuty key. But note, we've learned that manually entering in PagerDuty keys is error prone. You've seen those keys, they're like 20 characters, just random characters. And invariably someone's going to fat finger like the last character, and then the whole paging paradigm is broken. So what we've done is that we have created a linkage between PagerDuty service keys and apps and allow you to select the corresponding service name. Tight integration with PagerDuty reduces the time to fix an issue by making it really, really easy to get a hold of the right people. So as I said earlier, we definitely advocate guardrails and accept that accidents still happen. As such, we want to make it as easy as possible to get a hold of accountable people who can solve the issue as soon as possible so that you can continue to watch your favorite content on Netflix. And so our tooling provides these guardrails to avoid major disasters. But again, I can't stress, we accept that failures will eventually happen. People make mistakes. We're all human. So as such, we conduct blameless postmortems so we can learn from these mistakes and not repeat them. And in these postmortems, there's no finger pointing. All of us at Netflix has probably done something that has broken something in production, and we're still here to talk about it. In fact, many of the best practices I'm sharing with you, regarding how to effectively run in a multi-region environment have come right out of these postmortems. So in summary, if you really want to rapidly deliver software across multiple AWS regions, please, please, please avoid simultaneous regional deployments. Use red, black, or blue-green deployments. Use deployment windows, especially if you have cyclic traffic patterns or you want to ensure you have the most hands on deck during a particular deployment. Obviously, leverage automated testing as a part of your pipeline. If you don't have automated CANARY analysis functionality at your particular company, unit integration functional testing are obviously all part of this mix. They should be part of your pipeline. Automate everything, especially those one-off manual tasks. Avoid email if you need to get a hold of people in real time. Recognize that sometimes humans, we can make good decisions, sometimes better decisions than our computers. Please don't make a you-know-what out of you and me. And finally, make it really, really easy to find accountable people so you can limit the time to actually provide a fix. So Netflix is here at AWS reInvent because we're hiring. If you want to work for Spinnaker, work on Spinnaker, or you want to do something else at Netflix, please come by, talk to me or any other Netflixer here at reInvent. We have a booth. Come chat with us. We'll be happy to talk to you about all the awesome stuff we're doing at Netflix. We also have plenty of stickers, so please stop by and grab some stickers. If you'd like to learn more about Spinnaker, we have a website, Spinnaker.io. There's a ton of documentation, videos, links into GitHub repositories. Also, there's a link into our Slack channel, and that Slack channel is very, very active. Not only is Netflix participating in it, but other large corporations and people from the community. It's a very, very rich ecosystem of people that are more than happy to help you. Even better, if you want to talk more about Spinnaker, if you have some ideas to share, if you want to learn how we do things, we'd love to hear how you do things. Come to booth 720. That's the Netflix booth, and come chat with the Spinnaker team. We'll be there after this. There's 6 of us. And in fact, right after this talk, we'll stand over here if you want to talk with us as well. I will say I left time to take questions. So if you have any questions, I can take them right now.